Have you ever wondered about self-driving cars? Imagine sitting inside a car. The car can drive itself, no hands on the wheel, no feet on the pedals, just one destination. A machine makes thousands of decisions. It does this every single second. Only a few years ago, this sounded like science fiction. Today, it is reality. No company has pushed that vision further than Tesla. But here is the question. It changes everything. How can a machine safely drive through busy streets? These streets are full of cars and people. They have cyclists and traffic lights. They have road signs. They also have unpredictable human behavior. Can a car really understand the world? Can it see like humans do? Or is it simply following programmed rules? The answer may surprise you. Tesla is not just building electric cars. It is building advanced AI systems. It is one of the best in the world. Tesla cars are designed to learn. This makes them different from old cars. Every mile driven helps. It improves the intelligence behind the system. Millions of Tesla vehicles drive every day. They generate valuable driving data. This data helps engineers. They use it to train the software. It improves future versions of the system. This approach helps Tesla. They can continuously refine their AI. The system learns to recognize roads. It tracks traffic and complex driving situations. But Tesla chose a unique path. This makes them truly different. Many companies spent a lot of money on expensive sensors. These are laser-based sensors called LiDAR. Tesla took a completely different approach. Tesla did not teach cars to rely on laser maps. Instead, Tesla focused on cameras. They teach the AI to see the world through cameras. This is just like humans who rely on their eyes. It was a bold decision. Many experts questioned this method. They doubted the cameras. They wondered if cameras alone could be enough. They worried about safe, autonomous driving. Some believed Tesla would never succeed. Others believed it could change things. It could change the future of transportation. So why did Tesla take such a huge risk? The answer is very simple. Humans do not drive using laser scanners. We drive by seeing the world. We recognize patterns. We judge distances. We predict movement. We make decisions in real time. Tesla's engineers believed in this idea. AI could learn to understand visual info. It could do it just like humans. Then, self-driving tech could become accessible. It would be easy to scale. To make that possible, every Tesla has multiple cameras. These are high-resolution cameras. They are positioned around the vehicle. Together, these cameras create a great view. It is a nearly 360-degree view of the environment. Every second, they capture a lot of visual info. They see cars changing lanes. They see pedestrians crossing streets. They see cyclists at intersections. They capture traffic lights changing colors. They see construction zones, road markings, and many other details. But cameras alone do not make a car smart. Your eyes do not make decisions. Your brain does. That is exactly where Tesla's true innovation begins. Behind those cameras is an AI system. It is powered by advanced neural networks. It can interpret what the cameras see. It decides what the safest action should be. It does not simply identify objects. It attempts to understand the environment. It predicts what might happen next. It responds in real time. That is the foundation of Tesla's vision. It is their core plan for autonomous driving. But seeing the road is only the first challenge. The real question remains. How do you teach a machine to think? How can it think like an experienced driver? The answer is simple. You do not write millions of rules. That would be impossible. Roads are unpredictable. Every city is different. Every driver behaves differently. Every second brings a new situation. No engineer could predict these events. Instead, Tesla teaches its AI through experience. This is the same way humans learn. Every day, millions of Tesla vehicles travel. They drive on highways and crowded city streets. They use rural roads and neighborhoods around the world. During these journeys, the cars face real-world situations. They face heavy rain and dense traffic. They see unexpected road construction and difficult intersections. This driving data helps engineers. They use it to improve Tesla's AI models. Over time, these improvements are sent to many vehicles. They come through software updates. This allows the system to become more capable. Behind this process are powerful neural networks. Think of a neural network as a digital brain. It is designed to recognize patterns. It does not memorize every possible rule. Instead, it learns by analyzing real-world examples. It looks at enormous numbers of examples. The more situations it processes, the better it becomes. It gets better at recognizing objects. It understands traffic behavior and predicts what is likely to happen next. Imagine teaching a child to cross a busy street. The first time, everything looks confusing. Cars move in different directions. Traffic lights change. People cross unexpectedly, but the child sees the same situations over and over. Then, the child begins to recognize patterns. The child makes better decisions. Tesla's AI learns in a similar way. It can be trained on a lot of data. This driving data is collected over time. But learning is only part of the challenge. The real test begins when something unexpected happens. Imagine driving at 65 miles per hour. Suddenly, a child runs toward the street. A cyclist swerves to avoid a pothole. The vehicle ahead slams on its brakes. In moments like these, there is no time to wait. Tesla's AI must rapidly analyze the environment. It must estimate how objects are moving. It predicts what could happen next. Then, it determines the safest response. Its goal is not simply to react. Its goal is to anticipate. Could that parked car suddenly pull into traffic? Will the pedestrian step into the crosswalk? Is the truck in the next lane about to merge? These predictions happen continuously. They run while the vehicle is moving. This ability to anticipate future events is a major challenge. It is one of the hardest problems in AI. People do not always